Hi everyone, and welcome to this tutorial on Ucancam, a powerful software designed for CNC machines. In this video, I'll take you through everything you need to know on how to get started with Ucancam, from understanding its interface and tools to setting up and running a project from scratch. Ucancam is widely used for creating designs and generating toolpaths for CNC routers. It's known for its versatility and precision, making it a great choice for both beginners and experienced users. Whether you're working with wood, acrylic, composites, or other materials, Ucancam gives you the tools to design, simulate, and execute complex machining operations with ease. So let's jump right in and start with an overview of the interface. After we launch the software, we're greeted with its main interface, which is organized in a few sections. A section containing all the main functions from the main menu bar. Right beneath it, there is a section with most commonly used tools. On the left side of the interface, we have the drawing toolbar, and it contains tools for drawing lines, polylines, squares, circles, polygons, and other basic geometric shapes. Beneath it, in the bottom left section, we can find the tools for alignment. The right section contains the selection tools, the design central bar, and the vast majority of the newly opened windows appear in this area. And finally, around the perimeter of the drawing, we have the positioning ruler. We will use all of these tools to create our drawing, and after we're done with the design, we can assign toolpaths and toolpath operations. We can begin by defining the size of our working area, and we can do this in the Design Central tab, which is located in the right corner. In the first field, we input the width, and in the second one, we input the height of our working area or our workpiece. After we're done with this, we can use some of the tools from the drawing bar and draw a few basic geometric shapes. I will add a rectangle, a circle, and some text as well. Ucancam has the ability to modify and transform all kinds of vectors. We can merge, trim, subtract, offset, and much more. For example, I can combine all of these shapes and merge them in a single one. First thing I need to do is to remove all the internal lines from the design by selecting all the vectors and choosing the option Trim, which is located in the main menu bar in the Modify window. With the option selected, we position the mouse cursor over the vectors that we want to remove and click on them. As long as they intersect with the surrounding vectors, we have the option to cut them completely. With this, the software removes the unwanted vectors and we can continue with the other operations. What I want to do with the remaining vectors is to join them in a single group, and I can do this by selecting all of them and choosing the option group. The option Join can also merge intersecting shapes by removing all internal vectors. After we've done this, we need to select the remaining vectors which I want to be included in the final shape and choose the option Group, which can be found in the Modify window. With this option, we add all the selected vectors in a single entity. Next thing I'm going to do is to change the dimensions of the drawing, and I can do this by selecting all the vectors and inputting the desired value in the Design Central window. If we haven't selected any objects, the Design Central window has a few fields in which we can enter the width of our workpiece, its length, its orientation, and set up the origin point. But if we select any vectors, the same window, the Design Central window, will display its properties, the properties of the selected vector, such as its dimensions, its position, and its orientation. In the field DX, we input the desired width of our design, and in the field DY, we input its length, and in the fields below, we input the desired position of our vectors. In the X field, we input values for precise positioning on the X-axis, or left and right, and in the Y field, we input values for the position on the Y-axis, or up and down. If the button proportion is clicked, then when we change one of the values in dx or dy, The other one will change proportionally so that the vectors maintain their original shape. And in the field below, we can determine the angle of rotation for our selected vectors. What I need to do is to change the dimensions of my drawing, and I will input the desired value in the dx and dy fields. After we are done with this, we can continue with our design. What I would like to do next is to import a previously prepared and drawn file, and I can do this with the option import, which can be found in the file window of the main menu bar. After clicking it, a new window pops up named import, and in it we need to locate our file, we need to select it and click the open button, or we can just double click on the file. Ucancam works with DXF, AI and other vector formats. In our case, we will work with a DXF file. After we click on the open button, a new window pops up named import DXF file, and in here we need to uncheck the create DXF layer option and select millimeters in the unit window. We click on the OK button and the software displays a frame around the perimeter of the drawing. We position the mouse cursor where we want our vector to be and use the left click to place it. What I want to do with this project is to manufacture a tabletop sign built in two separate elements, the sign and the stand for it. First thing I'm going to do is to create the stand. I will draw a rectangle, and in the window Design Central we can notice some additional options which enable us to choose the type of corners for a rectangle. We can choose between regular rectangle, fillet rectangle and chamfer rectangle. I will select the option fillet rectangle and complete the drawing. Next thing I need to do is to select our newly drawn rectangle and choose the option offset, which is located in the modify bar at the top left corner. After I click on it, a new window will appear in Design Central and it's named offset. In the first field, named distance, we input the desired value for the distance between the original and the newly generated shape. In the field below, named direction, we can choose whether the software generates the offset on the outer perimeter or inwards, in the inner region of the drawing. I'm going to choose the option inwards. Right underneath this field, we have the option offset corner type, which sets the corners of the newly generated offset accordingly. I'm going to choose the first option, or sharp corners. We are going to use both of these lines to create a toolpath for this region. What I'm going to do next is to slightly modify our imported DXF file. I need to draw an additional section which will enter the machined region of the stand. I'll start by adding another rectangle and modify its dimensions. I will set its height at 12 millimeters and its length at 150 millimeters. I will reposition the newly drawn rectangle so that it barely overlaps with the bottom section of my drawing. After I'm satisfied with its position, I will use the option trim to remove the unnecessary overlapping vectors. Now my sign has a fixture point which will be inserted in the grooved section of the stand. Speaking of which, I need to draw the grooved section in the stand. I'll draw a rectangle and assign its dimensions. In our case it will be 150 millimeters length and 15 millimeters width. Our material has a thickness of 18 millimeters, but I plan to lower the thickness of the sign for 3 millimeters with one of the operations, which will make the sign 15 millimeters thick. I'll select the newly drawn rectangle, and by holding the Shift key on the keyboard, I'll select both vectors of the stand. Once they're all selected, I'll use the option vertical aligning and horizontal aligning, which can be found in the menu bar Align in the top left corner. These options will perfectly align all selected vectors. And once we are satisfied with the result, we can continue with grouping and merging vectors. If I click on the letters, we can notice that they are all in a single group, but the same cannot be said about the vectors around them. So what I need to do is to select them. I can do this by holding the Shift button to select multiple vectors, and I'll navigate to the main menu bar, Modify, where I'll choose the option group, which can also be done by pressing the Ctrl+G buttons. With this operation, the software successfully grouped the vectors. And next thing I'm going to do is to assign toolpaths and toolpath operations. We'll start with the sign. So what I want to do with it is to remove all the material between the letters and the perimeter of the sign, and I'll use the outer vectors to set up a second toolpath, which will cut off the shape of the sign. I'll use the operation profile machining and area clearance to achieve this effect. But what is profile machining and what is area clearance? Let's take a closer look at these commonly used toolpath strategies. I'll start with profile machining. So profile machining is used when you want to cut along the edge of a shape or outline. It's perfect for cutting out parts, for creating contours, or for engraving borders and various similar applications. I'll start by selecting the outer vector of our sign and click the option Profile Machining, which is located in the Toolpath menu bar in the top section of the interface. As we do this, a new window pops up to name Profile Machining, and in its first section named Tool Library, we need to choose the adequate tool for this operation. We click on the Tool Library button and a new window opens up named Tool Management, in which we select our tool. I will work with an end mill, which has a diameter of 3 millimeters, and I can locate and select the tool and then click the Close button. If our knife is not in the tool database, we can easily add or edit existing tools by clicking the buttons Add or Edit in the lowest section of the tool management window. When we add or edit tools, we need to input its diameter, its maximum cutting depth. This is the maximum increments for which the knife can progress into the material, and it's independent from the final depth. Also, the RPM of the spindle, the feed speeds of the tool. The feed speed is the maximum speed at which the knife will engage and remove the material once it has progressed into it. And we have also the plunge speed options, which determine the rate at which the knife will enter the material. After we are done with setting up these settings, we click on the OK button and click on the Close button to exit the tool management window. Right beneath the Tool Library button, we have the option Plunge. This option controls how the tool enters the material at the beginning of the cut. Some tools can't enter the material moving straight down or vertically, especially the end mills, since most end mills are designed to cut efficiently on the sides rather than the tip. Plunging helps to create an angled starting point for the cut and ensures that the tool engages the material properly. This kind of knife must enter the material at an angle, and this is where this option comes in. When enabled, the software gives us access to the entry-exit window, in which I'll choose the option Ramp Down and set the angle at 30 degrees. With this, the software sets a diagonal path at an angle of 30 degrees, which the tool will follow when entering the material. Our other options are the Picking Plunge, which allows the tool to enter the material in small steps or picks, rather than in one continuous plunge. The tool will plunge down a set distance, it will retract slightly to clear chips and reduce heat buildup, and then repeat the process until the full plunge depth is reached. And our final option is Lead In, Lead Out. In the section Lead In, we set the parameters so that the tool starts the cut slightly away from the shape to avoid visible marks. And lead out option sets the tool to finish the cut outside of the shape for a cleaner finish. After this, we need to determine a cutting position relative to the vectors for our design. In the field named cut positions, we have three options: on the line, outside the line, or inside the line. If we choose the option on the line, the tool will cut directly along the shape's path, right on top of the vectors, which is pretty useful for engraving. The option outside cuts along the outer edge of the shape, which is useful for cutting out parts which need to have the exact specified dimensions. With this option activated, the software will take into consideration the diameter of the knife and reposition its toolpath accordingly, so that when the machine cuts off the parts, its dimensions are exactly as we previously determined. And the final option, inside, this option cuts along the inner edge of the shape, and it's good for creating holes or recesses with exact dimensions. It's basically the same function as outside the line, but it has the opposite effect. In the field named cut parameters, we have a few options, and the first one is named total depth. In this field, we input the final depth for our design. What I'd like to do is to cut this section off completely, so for our case the total depth will be 18.2 millimeters, because my material is an MDF board and its thickness is 18 millimeters. In the field sequence, we control the order in which the toolpath is executed during profile machining. If we choose X first, the tool will complete all the cuts along the X-axis before moving to the Y-axis. This is useful when you want to minimize rapid movements between the axes. If we choose Y first, the tool will complete all the cuts along the Y-axis before moving to the X-axis. And if we choose near first, the tool will start cutting from the location closest to the current position of the tool, reducing overall travel distance and improving machining time. We're going to choose this option, near first. Right below we can find the option side allowance, which allows us to leave a small amount of extra material on the sides of the profile cut. It's useful for finishing passes where you want to make a rough cut first and then remove the remaining material with a lighter pass to improve accuracy and surface finish. A positive value leaves extra material, while a negative value will cut slightly into the profile. Right underneath it we have the option multi-layer, and if we activate it, it will allow us to break down the cut into multiple depth passes instead of cutting the full depth in one go. It's useful when working with thick or hard materials, as it reduces the load on the tool and prevents overheating or tool breakage. We can set the depth of each layer to control how much material is removed per pass, ensuring a smoother and more precise cut. In our case, I'm going to input a conservative value of 3 millimeters, which tells the machine to reach the final depth of 18.2 millimeters in 6 passes and complete the cut. In the section cut direction, located right below multi-layer, we can choose between clockwise, which moves the tool in the same direction as the material feed, or anti-clockwise, which moves the tool against the material feed. Another additional option that we can choose is the option bridge, which adds tabs along the toolpath of the material. So tabs are small uncut sections that keep the part connected to the material until the cut is finished, and we can remove the tabs manually after the machine has finished the job. When all the settings are adjusted, we click on the OK button and the software will generate the toolpath. If we zoom in, we can notice that the software generated the toolpath with the color blue on the outside of the selected vectors, and it's offset from the original vector for half of the diameter of the tool. What we need to do next is to select the newly generated toolpath, and from the menu bar toolpath we need to choose the option toolpath output. After we click on it, a new window pops up in the Design Central section named Toolpath Output. In the first field, we select the adequate post processor, and right below it, we set up the origin point of the drawing. The values we input as origin determine the reference point from which all toolpath movements are calculated. It's the starting point for the machine's movements and can be set at different locations, like the corner or the center of the material. By defining the origin, we ensure the toolpath is aligned correctly, ensuring accurate cuts and preventing error in positioning. In our case, I will use the bottom left corner of the workpiece as an origin point, and to do that I need to input the adequate coordinates for x, y, and z axes. All of them will be 0. If we click on the button Pick, the software gives us the option to point and click on the work surface where we want to set our 0 position. I won't use this option, instead I'll input the values manually. Beneath this is the field Tool, in which we set up the safe height. This option defines the height at which the tool will move safely above the material when traveling between cuts or moving to a new position. It ensures that the tool doesn't accidentally collide with the material or clamps, preventing damage. The safe height is typically set above the highest point of the material or workpiece, allowing for smooth collision-free movements without affecting the cutting process. It's essential for preventing tool crashes during rapid movements. So the final and only remaining thing to do is to choose a location where our toolpath will be generated and saved at. We need to click on the small folder icon in the newly opened window and choose our location and name the file. After we are done with this, we click on the Save button. With this, the software has successfully generated our toolpaths for cutting off the sign from the material. When we load this file into the machine, we need to make sure that the correct knife is equipped. In our case, it's the 3mm diameter end mill. And we need to make sure that the origin position is at the bottom left corner of the workpiece, identical to the origin position we set up in the software. So now we can move on with the remaining vectors and toolpath operations. Next thing I'm going to do is to select the letters and the outline of the sign, and from the toolpath area select the option Area Clearance. After we click on it, a new window will pop up, amply named Area Clearance. In this window we have a few options similar to profile machining with some differences. In the field tool library we select an adequate knife. I will use the same end mill with diameter of 3mm. In the field below I enable the ramp effect because we are still using the same end mill tool. Right next to it we have the machining strategies, and the choices are raster, offset, and spiral. The offset function uses geometry which starts from the middle of the part and gradually works its way out to the outer perimeter in the shape of a series of concentric passes. If we choose the raster option, it will start from the top section of the vectors and it will move in a zigzag fashion, all while clearing the material. And the final option, spiral, moves the cutter head in spiral motion, starting from the midpoint of the selected vectors and gradually working its way outwards. I will check the multi-layer machining option and set a step depth to 1mm. In the neighboring section, machining parameters, I need to input the value for the final depth in the window total depth, and in our case it will be 3mm. So after the machine finishes all the passes, our sign will be 3mm thinner, except the letters, which will protrude from or stick out from the surface of the material for 3mm. The final option is the overlap ratio, and this function determines by what percentage our toolpaths will intersect with each other. This setting will determine how clear and smooth our surface finish is. So I believe that 20% is good enough for our application, and I will leave it as it is. We check the option mill contour, we choose the clockwise direction, and we click on the OK button. With this, The software generates the toolpaths for the area clearance and it displays a graphical representation of them. The blue lines indicate the toolpath. Now our sign is complete, and what's left is the stand to which we will attach it. I'll manufacture the stand from MDF. I'll use the same board for the sign and for its stand. What I'll do next is select the outer vector of our stand and assign in the profile machining operation. I want the machine to cut through this vector, and I will use the outside option so that the final dimensions of our stand are according to the specified values. I will use the same 3mm end mill, and the total depth will be 18.2mm. I'll check the multi-layer options and set its value to 3mm per pass. I'll make sure the plunge box is ticked, and once I'm sure that all the parameters are set, I'll click on the OK button. Next thing to do is to add a toolpath to the inner vector, which is where the recess of the stand will be. In the recess we will attach the fixture portion of the sign. So I will select the inner vector and from the toolpath bar choose the option area clearance. Once the window opens up, I'll need to set the total depth to 16mm because the height of the fixture part on our sign is 15mm, and I'll also take 1.5 millimeters from the surrounding area. I'll leave the rest of the parameters as they are. I select the newly generated toolpath and export it with the function toolpath output. The last operation I need to assign is area clearance in order to remove a few millimeters in the area between the inner and middle vectors of the stand. I will select both of them and choose the option area clearance. In the designated window, I'll input final depth of 1.5 millimeters and I'll use the 3mm end mill tool for this operation. The values in all other fields are acceptable, so I'll leave them as they are. Again, I will click the OK button, and after I make sure that everything is in order with the newly generated toolpath, I will export it with the function toolpath output. With this, we have finished all operations in Ucancam, and we can transfer all exported files into the controller of the machine. The only remaining thing to do is to manufacture our sign. Well, that wraps up our tutorial on Ucancam. Awesome and reliable CNC software that makes designing and machining easier and more precise. Its powerful features and user-friendly interface make it a go-to choice for both beginners and professionals. I hope you found this helpful and feel more confident while using the software. Happy machining, and I'll see you all